Right, this is quantitative data analysis techniques. It's assignment 4.5. So moving on to 4.5.1. I'm going to give a brief introduction where I'm going to talk about the hypothesis, numerical data, normative data, and how you present data. So, first of all, starting with the hypothesis. A hypothesis is a specific statement or prediction made at the start of a study or research project that states what the researchers will think will happen at the end. To perform a realistic hypothesis, it needs to be testable so that you are able to gain information about the study. There also may be one or more hypotheses in a single study looking at the same test but with multiple predictions. There are three main types of hypothesis. These will include null, alternative, non-directional, two-tailed, and one-tailed or two-tailed. One-tailed is directional and two-tailed is non-directional. So a null hypothesis states that nothing will happen in the test and everything will stay the same. It means that there will be no significant difference, and the difference that will happen in the test will happen by chance rather than manipulation of the independent variable. An alternative or one-tailed hypothesis predicts that something will change, and it can only change in one way. It predicts that something will happen in a linear fashion. An example might be that if an owner puts food in their dog's bowl, then a researcher might hypothesize that they will eat the food. And if it's one-tailed, they'll hypothesize that they will only eat the food. And if it was a two-tailed, they'd say the dog might eat the food, or they might not, because it could go either way. It's got no direction. So that is an example of a one-tailed hypothesis compared to a two-tailed hypothesis, which has no direction. So, for example, something may happen both ways, like I just said. Conducting qualitative research will mean you will collect numerical values from your data. This is useful from comparing to other data, such as the normative data, other studies' values, and it is much more easily presented in graphs and charts. Comparing your data with the normative data of other studies can be useful to spot anomalies when comparing the data you found. Presenting data also becomes much easier as well. This is because numerical values can be implemented easily into graphs and charts, which makes interpreting data much easier for people looking at that specific study. This is in contrast to qualitative data, which is much more time-consuming to view the results of a study. So moving on to the organisation part of the assignment. So first way you might organise your data is rank order distribution. So Adams et al. 2010 stated that rank order distribution means placing your data into an ordered list from the lowest to the highest values. Rank order distribution is used when the group of participants is equal to or greater than 20. An example of when you would use rank order distribution might be when ranking scores in a competition. These scores shown on the slide shows the score on a vertical jump test. If this was a competition based, then the idea was to see who got the highest score in a test. Rank order distribution would be helpful in seeing who had the highest and who got the lowest easily without reading through all the scores. This is often used in competition while the competition is still going on to show who is currently in the lead. Sports that use these rank order distribution displays are usually individual sports. These might include athletic events, gymnastics, skiing, and many more. Rank order distribution is easy to manage as well, as it means all the value it is sorting all the values into a order of highest value to lowest value. For example, a basketball league might use rank order distribution in their league leaderboard to show who is currently at the top and who is currently at the bottom. And it is also then easy to find the range, the mean, and the mode after organising your data into a rank order, because all the numbers are in highest to lowest form. So moving on to the range. So the range is, I've got a definition here. Adams et al. 2010 states that the range is the distance and the numerical value from the highest to the lowest collect. So, for example, in this one, The lowest was 15 and the highest was 56 in vertical jump scores. So 56, to get the range, you need to take the higher number and subtract the lower number from the larger number to get the range. The range is similar. There are benefits and disadvantages of using the range. One main disadvantage is that if there are a lot of low numbers and only one large numerical value, then it means that the range will be a higher value overall, and therefore it won't be representative of the data set and will be an accurate way of presenting and organizing the data, because if all these numbers were maybe 3, 4, and 5, and then this one was still 56, you'd be taking away maybe 3 from 56, and the range would be 53, when that was only representative of one large number in the whole data set. So it can be misleading, because it only includes both the extremes in the data set, so it's quite vulnerable to anomalies and outliers. So simple distribution frequency, where the frequency is higher than 2, it means that this value has occurred twice in the dataset. For example, for the sit and reach test, 2 people scored 25, 21, and 3 people scored a score of 27. So here I've got my sit and reach scores, and instead of this representing an individual, this represents the frequency that this score was actually achieved. So 25 was achieved twice by 2 people, 27 was achieved 3 times, and then all the other scores were achieved twice for 21, and all the others were achieved once. So this is basically the frequency that value actually happened. So simple distribution frequency is when the data set is collated and put into a frequency chart showing how many times each value occurred. Simple frequency might be used in a basketball game. In a basketball game, there are 3 different amounts of points you can receive for scoring at one time. These are 1 point for free throws, 2 points inside the 3-point line, 3 points outside the 3-point line. Simple frequency distribution might be used to show how many times a team or individual score 3-point shots in a game, and so on with the other scores. It is helpful to see initially how many times the value has happened, and is easy to read quickly. So moving on to 4.5.2, this is part 2 of my assignment, which is presenting data. So presenting your data is very important to making sure that your findings are readable and understandable with other researchers and also people interested in the research study. This means that the graphs and charts chosen are suitable with the data that you are using, so that it is as clear as possible for people looking at it. They also need to be labelled with measurements so that it is clear what the graphs and charts are showing. And now I'm going to go into some of the graphs and charts you might use when conducting a research study and presenting your findings. So first 2 I've got here is a bar chart and a scatter plot. So bar charts are the best used to show the differences in values in the data set, as it is visually easy to read. And another important thing about presenting your data is that you need to make sure you pick the correct chart or graph for your data, because if you're measuring for difference or correlation or relationship, they're going to fit a different graph. So for example, a scatter graph here is actually measuring correlation, so the relationship between two values, so flying sprint times and standing vertical jump, to see if there's any relationship between those 2 topics, whereas this maybe wouldn't work with another topic that only has one variable. So you need to make sure that you're testing for difference or relationship, and then make sure that you choose the correct graph accordingly, so that your data is presented in the best way. So the bar chart is a simple chart that shows the difference in values. You can use more than one data set at times in one graph, so it can be good for comparing the normative data to your own. The bar chart are visually easy to read, and it means that they can be interpreted quicker, and therefore it's less time consuming. This chart, however, does not go into much detail as it doesn't state if the values share a relationship at all. So it can only tell you the values of each individual in mine. It can't tell you the relationship between those values. So the scatter plot. So this looks at the relationship between variables and can show if there is a correlation. So this basically shows if there is a relationship, like I was saying, and this relationship will either be positive or negative, or have no correlation, or have varying degrees of correlation. So the scatter graph, however, does not show a correlation. Does show a correlation or relationship between values, and this can either be positive or negative depending on the data that's used. As you can see in the diagram, there is no correlation between my values. A line of best fit has been added. This can be useful with the correct data. Some data with only one variable data set will not work with scatter graphs. Scatter graphs are effective for showing the correlation between two values of things. It is also relatively easy to see the data immediately and see if there is a positive or negative correlation between the two things, and also how strong the correlation is. The downside to a scatter graph is possibly if someone has never seen a scatter graph before, they may not be able to interpret it at first glance. But if you have basic knowledge about this graph, then it is simple and straightforward to look at the results. And it can be useful to know if two things such as height and vertical jump share a correlation. This is the best graph to showcase this because you can immediately see if two things share a correlation. And it is good to see because you can see on a varying degree how strong the correlation is, if it is positive or negative, and it gives you quite a lot of information about the relationship between two values if that's what you're interested in. So moving on to line graphs and histograms. So the line graph is a chart used for showing difference or a comparison between two values, and is also it can also show how results develop over time. However, I've not used that in the example I've used, and you can use multiple sets of data at once. So the line graph is a good show of data and it's very easy to visually interpret immediately, especially arranging values like mine in the diagram. It is easy to see the spread of data, and this is a positive because if your table is visually easy to read, then more people are going to be able to understand it, and more people other researchers will be able to understand your findings, basically. You can also see with the line graph that I've added SD bars, standard deviation bars, or error bars here, which you can see in between the lines, which are the black sticks. And an error bar is a line for a point on a graph parallel to one of the axes, which represents uncertainty or variation of the corresponding coordinate of that point. So basically, it is determining the standard deviation from the mean point of the values, and if they overlap, it means that the data is likely to be statistically significant, and if they do not overlap, then they are not likely to be statistically significant. So moving on to a histogram. So a histogram is defined as a graphical display of data using bars of different heights. In a histogram, each bar groups numbers into ranges. Taller bars show that more data falls in that range. A histogram displays the shape and spread of the continuous sample data. So we can see here that what they were talking about was in this range of 1.95 to 3.75, 14 participants have basically scored between that range, and therefore this is why this bar is so much higher than this bar, because only one person scored in that range. And this is good for immediately seeing how the data varies, and if there was a wide spread of data, So, for example, in this test, that we can see that there wasn't a widespread of data, and most of the results came between 1.95 and 3.75. So it's good for